Hi, welcome to this new SimplyMaya tutorial. In this tutorial we're going to cover how to get the best out of mental ray for post-production. In order to do this we're going to cover quite in depth the process of using render layers, render passes, the difference between the two, when you should use each one. Before we get started, however, I just wanted to work you through the process of what's called linear workflow. Now, if you already know this in Maya, you can skip straight ahead to the second video, but for those of you that don't, I want to illustrate now the importance of it, why you should use it. So we'll get started. This is the scene we're going to be using for this tutorial. Really, it's just a very simple interior. We just have 6 lights here. And if I pop up the render window, just to demonstrate how important linear workflow is to you, this image rendered is a non-linear workflow, and this is using what they call the linear workflow. Now, the difference between these two things is Maya actually calculates in linear space. The viewer, on the other hand, shows you a linear image. Your monitor wants a gamma corrected image. So this is what your viewer will show you by default. This is what we need to get it to. Otherwise, you'd be turning all the intensity of these lights up to get this result, and that wouldn't work, because then you would have extremely bright hotspots here, and you're never going to quite get your overall lighting level correct. If I was to take this image now, save it out, pop it into, say, Photoshop, and increase the gamma to 2.2, it would look exactly the same as this, basically. The problem is that while you're rendering and doing your test shots, you need to be able to see what your actual final result will be, not what Maya wants to show you. I mean, not using a linear workflow in Maya is kind of like working in a pair of really dark sunglasses. You really will need to crank all the lights up to such a level that your image is just never going to look quite right. So in order to demonstrate this, I'm going to just pop open a new scene here, and I'll demonstrate the importance of this once again. I'll bring my grid back, and I'll just start with a very simple polygon plane here. Okay, and if I introduce a light, I can show you what I mean. So let's just go for an area light. I use an area light because it has natural decay on it. Okay, so I won't need much, just something like this to demonstrate this. And if I render this now, you'll see what I've got is an intensely bright hotspot, but with an extremely quick fall off. So what I've seen a lot of people do is, to get rid of this hotspot, they end up moving the light back here, and then we render, but we still got not a lot of light. So I mean, this is where a proper workflow really aids you, because if I crank this up to 30, now I've got an illuminated scene, but I've still got this huge hotspot. So once again, back with the light, and that's a bit better, back a bit more, and that's kind of what I was looking for, a much more gradual fall off. Let me just change this render size here. There we go. You might be able to see a bit better what I'm talking about. So now I've got this sort of gradual fall off that I wanted, and everything is lit. This is still too dark, and this is still too bright. And here is our light. It's all the way back here. So what can happen if you're not using what they call linear workflow is you end up with having to place your lights miles away from the object you're trying to light. Now, this is fine if you're lighting up a character. I wouldn't say it's fine, but you can do it. However, if you're lighting up an interior, and this is the floor of our interior, then our light would need to be in the room, which would cause this to happen. Obviously, no good. And if I set this intensity to 1 to get rid of that hotspot, we've now just got nothing but a hotspot. I can't see anything. So one of the processes in working with a linear workflow is to gamma correct this view to what it should be, a gamma of 2.2. And there really is a rather easy way to do this. If you select the camera you're working with, in this case I'll just use the perspective, under lens shaders, if you pop that open under mental ray, you can go to mental ray lenses, Now you've got two ways of doing this: exposure simple or exposure photographic. I'm going to use the simple one. The reason I use the simple one is I prefer to do this in post-production. Gamma correction, compression, the f-stop and whatnot. I prefer to take care of that in post. All I'm trying to achieve here is to have a render view that looks as it should. So let me just pop that onto mental ray, and I'm going to bring up the compression to 0 and the knee to 1, because I don't actually want to do anything with this. I'll show you what these settings do, it's just out of interest if you want to know. But what I want is a pretty flat lens shader, just to give me this gamma of 2.2. So if you'll remember, this is the last thing we rendered. I'll take a snapshot of that. I haven't changed the light, haven't really done anything, and there we go. I've still got this bright hot spot here, but as you can see, my image is now lit fairly well. I can see the gradual fall off, and if I want to get rid of this bright hot spot, if I just come back to here, you know, you can see that if I break the lens, if I break the connection on the camera, so let's snapshot that, and without changing anything, break connection, render again. So you can see what a massive difference this very small thing will make to your lighting. Okay, there's a couple of pitfalls though, isn't there always? If I were to put a texture on this, so let's just bring back our lens shader here. So pop open the hypershade. Under utilities, just middle mouse drag it. I don't need to create another one. I've already created one. So in hypershade utilities, middle mouse drag into that lens slot, and it will have kept all my old settings. So quick render from the top. As you can see, I've got the light. It's now quite nice. It's got a great fall off. Does what it's supposed to do rather than just showing me one hotspot with pitch blackness. So I'm going to zoom in on this so we can throw on a texture. Okay, get a shot, and I'm going to assign a new material. I'll just use a bog standard Lambert, and I'm just going to grab a texture for it. Okay, here's a floor texture I actually used for my interior. Alright, so this is a nice dark wood. If I render it now, you'll see what's happened is it looks very washed out, and those of you that have tried physical sun and sky may have run into this problem before, and it's for the same reason. When you activate physical sun and sky under the indirect lighting tabs, one of these lens shaders is automatically created, and what this has done is gamma corrected this view to a gamma of 2.2. However, this image has already been gamma corrected to a gamma of 2.2. So it's gammaed once before we brought it in, and it will be gammaed again now. So now we have a gamma of 4.4, which is why you get this sort of dull, listless, washed out quality to it. Now, a couple of ways to correct this. If you want to do it a more old-fashioned way, but at least we'll tell you what's going on, we can open up the hypershade, graph this. Under utilities, go for a gamma correction node. I'll just zoom that out a bit, and what we want to do is take the gamma off this image. So if we just break this connection, which is this file's out color to this Lambert's color, which I can show you here. Basically it means this has been connected to this color. So we'll break that connection, click our gamma correction node. We want to feed this image, so middle mouse drag, into the value of the gamma correction node, and then go 0.454, 0.454, 0.454. This will actually take the gamma off this image. So it won't be gamma corrected twice anymore. It's once when it comes into Maya, then we remove it, and then we feed it back into our Lambert. And you'll see here it comes in a lot darker, and then when we render it, it comes out looking like it should. Now that's one of the ways to do it. It can be a bit time consuming. You can find some scripts to do it for you automatically. However, if you're using Maya, I believe they introduced it in 2011. If you're using a version of Maya that's 2011 or newer, you can skip this process. So let's get rid of our gamma correction node. Let's just connect our texture back to our color. Okay. And we'll hit render, we'll get that washed out sort of texture again. But when we talk about gamma correction, we are basically just discussing color correction here. So if I go under the Common tab now and enable color management, it'll tell Maya that the default input profile of our textures is sRGB and we want the output profile to be linear. So what that's done is it's done the equivalent of that gamma node for us automatically. So if I hit render now, you'll see we get the nice floor color, and that corresponds in the viewport too. Now, once again, there are a couple of pitfalls with this. Because this is going to correct everything, if you've brought in, say, a normal map or a displacement map, something that you actually have in linear as opposed to a gamma corrected image, so a 32-bit image that's in linear space, this is going to do strange things to it. There's a simple workaround. If this had been a linear image, I just drop into its file node here, and under color profile I could just tell Maya that no, don't correct this, this was actually a linear image. Okay, so that's the reason we need to use a linear workflow in Maya. It's all about color correction and how the light works within Maya. This light has been calculated in linear space. This viewport is in linear space, which is no good to us because we need to see it so it works on our monitor. So in order to achieve that, it's a very simple two-step process. You need a lens shader for your camera, and I pretty much always use the simple one, because if I put this gain up to 2, you will actually see here our image gets twice as bright. There we go. Gain up to 4. And brighter still. Now, I really like to keep these things as flat as possible because I really like to get a sort of just a view of what the gamma is doing, and then I'll take these images into Photoshop, Nuke, After Effects, or whatever compositing app, post-production app you use, and we can do the corrections there. You have more control and more flexibility. The important thing is for you to be able to see what Maya is actually doing, and for you to see that, you actually need just this kitty here. You need the gamma. Okay, so I'll see you in the next part when we start with actual render layers. I hope I didn't bore you too much with this part. I just have to sort of go over the importance of why we'll need to work with a linear workflow in this tutorial, also the ways to do it, and some of the pitfalls of, say, enabling color management, and some of the pitfalls of doing it the more old-fashioned way when you actually connect up gamma nodes. Alright, see you in the next part. Thanks for watching. Hi, welcome back. In this part, I'd just like to discuss render layers and render passes, why you'd use them and what you'd use them for, and also the difference between the two. Now, in order to show you this, I've decided to just use the project I'm working on here, which is this quite simple interior scene, and I'm going to show you how I'd begin to split this up into its component parts. Now, the reason you do this is because you want to get this image into post-production as quickly as possible. With a render time of 2 minutes 27 seconds, this small image is not too bad. If I decide the light here is too bright, I can just go up and tweak all the lights here and re-render. The problem is when you start to get up to a higher resolution, so if I took this up to 2K, this is going to take 45-50 minutes to render, and that's when you run into this issue of tweaking lighting, small shading tweaks, or even large shading tweaks, like the specular highlight here is too ferocious, for instance. If you'd rendered out an entire animation of this, you couldn't really paint that out frame by frame in Photoshop. You could try it with something like After Effects, but simply the best way to work on these files as a post-production workflow is to split them up into all their component parts. Now before we get into that and how to put it all together again, I just want to show you quite simply what a render layer is first of all. So if I take all of my objects here, and I think my whole scene in essence, I think one of the simplest things to show you is how to set up a test layer. So this is 2 minutes 27 seconds, which is fine, but I reckon we could get this down to about, let's say, under a minute, which is better for testing. But I like this, so I don't really want to start poking around with it in random directions. What I'd like to do is create sort of a carbon copy for it, and then be able to override individual materials, render settings, and anything else, and then flick between the two. So I use my carbon copy to test out new textures, colors, shaders and whatnot, or even new light settings with a really fast render time, call it development render layer, and then I can go back to this and implement the changes that I like. So let's do this first of all. Select everything in your scene, go to the channels box, under render layers, you'll see here we've got one already, master. This one is created by default. So we've got everything here. Click this, which is create new layer and assign selected objects, and I'll just call this one test, let's say. If you can hear a loud clanking, that's me. I just bought a new keyboard, it's rather noisy, sorry about that. So now we have this test layer, and you'll notice that this clapperboard has gone to an X shape. This would just mean now that if I went to render, it would not render this layer, it would render this one. That's under batch render. So I can just do that, and if I hit batch render now, it will render both. So this is, for this point in the tutorial, irrelevant. I just thought I'd explain why this went red. Okay, so we have this test layer. Now, let's reduce the quality of it first of all. So we'll go into the render settings, and you can now see under our render settings, it's got in brackets test. If I click master, you'll see it now has master. So we want to make sure we're working under test, and let's go to indirect lighting, and what I'm going to do is right click, hit create layer override. You'll see this has gone orange. Now if I cut this in half, say to 30, when you go down here, you'll see it's still at 60. So I can really get to work, and you must remember to do this create layer override first. I mean, it's not going to be a world disaster if you don't. I'll show you what happens. I'll put this down to 0. When I come back here, this is also changed to 0. So very easy to fix. Create a layer override, set this one back to 2, this one will be at 0, this one will stay on 2. Okay, so you can do this with pretty much any setting you want. If you wanted to test what global illumination looked like with lower quality final gather settings, you can even turn things on. You can't just change them, you can actually, you can change whatever you would like, basically. So let's go on to quality and whack down the anti-aliasing. First, of course, remembering to create a layer override. So that's that down there, and shadow method to simple. Okay, so this is going to be the start of our test scene. So let's keep that one and render a new one. And you can see here as well, this now says test because we're on our test layer. So the other one took 2 minutes and 27 seconds, I think. Let's see how long this one takes, because obviously we want this one to be at least twice as fast, or it's not going to be much good as a test layer. Sorry. Okay, that's 38 seconds. So 2 minutes 27, 38. So now we have our test layer. We can test various things, and one of the nice things is, if I select this wall, for instance, and assign a new material to it, so just a standard grey Lambert, you can see if I switch back to the master layer that that's kept its material, whereas this has been assigned a new one. So now I can use this to test out different materials and things like that without interrupting my master layer, without interrupting my master scene. And there you go. I mean, this rendered, and you can see this is a plain grey Lambert on the wall now, as opposed to what we had here. So you can really start to test out materials. I can also see that this material I have on the wall, which is a mere material X, could probably use some tweaking. It's got some roughness, and just for that wall it's taking it quite some time. I was also connected to the floor, so it's probably a reflection on that. But I can really start to test out, you know, if you've got any wild, crazy ideas, but you get to that point where you've got a scene that you actually like the look of, so you don't want to go in and mess with all your settings, you're quite happy, but you still would like to test a few things out. Well, render layer is a great way for you to, you know, do some wacky stuff without actually damaging your scene. It's also a great way for you to test out scenes. Obviously this is why we called it test, but it's a nice use of a render layer, and for me it allows me to illustrate to you these layer overrides. You can also override materials, which is, as we said, simple enough. If you're actually on the layer, just assign a new material to it, and that will be done. Your master layer will not change. If you're wanting to override the materials on the entire layer, you can just go down to overrides, create material override, and let's say I wanted to assign a Lambert to the whole scene. Now I have overrided every single material in the scene, and it's just a plain grey Lambert. So you could use this to test a basic lighting setup as quickly as possible. You can use this also to see what's taking the time to calculate. Is it your materials, your settings, I mean, there's many things that can be done with render layers. This is just sort of my brief introduction to them. So that's what a render layer is. It's a bit like a display layer, but it deals with rendering instead. Quite self-explanatory, really. Okay, let's just let that finish, see what this looks like in grey. And you can start to see here the illumination, where it's coming from, yada yada yada. Okay, so that explains to you what it is. And now let's do something a little more useful than this. I always normally have one of these test layers, because I'm the sort of person that loves to try out, you know, off-the-wall ideas just to see what would happen, which, you know, without ruining an hour's work, this is a great way to do that. Let me just delete this layer. Okay, so I'm now going to show you what the difference between one of these and a render pass is. Now, the easiest way I can do this is to do something that you'd actually probably do with most of your scenes, which is ambient occlusion. So I'm going to create an ambient occlusion render layer, and then I'm going to create an ambient occlusion render pass and show you the difference and why you might use one in favor of the other. So once again, we're going to select our scene, but this time we're going to leave the lights out. Ambient occlusion, of course, does not need lights. So create a new layer, and we'll just call this AO, ambient occlusion, good enough. Okay, so there it is. Now, a couple of ways to do this. You can go to Attributes, under the AO, render layer, you can hit Occlusion. And what this will do is assign a surface shader to everything in the scene, and then it will assign a mental ray ambient occlusion material to the color out of that surface shader. The problem I find with this, if we go down and look at our layers, you see it's created a render override for us, which is nice of it, but I didn't want one. I wanted to use what I already had. So you will get an ambient occlusion with this. I will show you. We'll click on it, make sure it says AO up here, or whatever you've chosen to name it. And when I render, you'll see that I do actually get an ambient occlusion render. Shouldn't take so long. He says, of course, making him out to be a liar. Okay, there we go, done. Now, the problem with this is Well, A, it's nasty. I'll show you how to change that in a second, but the problem is these overrides that Maya's put in. I don't want Maya putting in overrides, I want to do that myself. So before we go any further and I show you how to get a decent one of these, what I'm going to do is just delete this layer. Okay, I'm going to select the geometry again, create a layer, and this one I'll call AO human. Human. Good enough. Okay, so what we have now is just a standard layer, same as when we created our test layer. There's no override on it at all, and we want to create the ambient occlusion. So to do this, I'm going to go overrides, create new material override, and I'm going to use a surface shader. Basically, I'm doing exactly what Maya did. I'm just doing it by hand, so I know exactly what's going on. If you let Maya make these connections for you, it can seem faster in the beginning, but what will happen is when something goes wrong, you can never actually be sure whether it was something you did, something Maya tweaked for you. You can end up hours of debugging, and this is really quite simple to do yourself. So what we'll do is we've assigned now a surface shader to everything in this AO layer, and if we go to material attributes, you'll see at the end here I should have a surface shader. Yes, I do. To the out color, want to go down to mental ray textures, and you'll see here MIB ambient occlusion. Plug one of those in, and you know what, if we render this now, we will get exactly the same result we got when Maya did it for us. So basically, that wasn't too painful. We made one connection, one material override, and we've created the ambient occlusion render layer ourselves rather than letting Maya do it for us. Okay, and you'll notice that when Maya did it for us, it took 1.5 minutes. Sorry, I think it was about 1 minute 10 seconds actually. When we did it for ourselves, it took 29 seconds. Why was that? Because Maya created some overrides in the render layer itself, up the quality probably of the anti-aliasing, and so the render took longer. I prefer to determine what quality I want my render at as opposed to letting Maya do it. So there we go. Now, splotchy, horrible mess. So although this is about render layers and passes, I will give you some tips on ambient occlusion. If you've done this many times, you can skip it, but the reason it's so blotchy is the samples are quite low, and also the max distance is set on 0. So it's allowing Maya to determine the max distance of the ambient occlusion. And I don't want this. I'm going to say a max distance of 25 units, which will give me a hard-edged occlusion around things like windows and all these details on the banisters here, but won't completely occlude these two back rooms. I'm going to keep the spread the same, and I'll keep the samples at 16, so you can just see what that one max distance change has done. Okay, and that's better ambient occlusion for me. I just want definition around the edges. I don't need ambient occlusion all across my walls and everything else. I have a well-lit scene. I don't need to fake that much GI. I'm already using global illumination, so this for me would just be a nice, extra definition of shadowing around certain objects. And obviously, if you want to blast up the quality of that, shouldn't really need to take it above 64 if you're using this style ambient occlusion. We'll just hit render, and that'll probably take it to about 30 seconds, I would think. Okay, good enough for demonstration purposes. Obviously you can take this up higher. If you change this max distance, let's say we change it to 500, grab here, you'll see what happens. Really, for most ambient occlusion, bright is the lightest colour, dark is the darkest colour. I mean, I think you can fairly work this out. When I set this max distance to 500, you can see my occlusion spread out all over the scene, which is not what I was looking for. It's a bit like having Maya guesstimate itself by putting this max distance to 0. So that's too much for me. So 25, 50, it depends on scene size and what you're actually trying to achieve. But in this scene, I'm just trying to achieve this nice sort of shadowing, extra shadow definition around these areas. So one other thing before we go on to a render pass and do the same thing. With a render layer, we've got one other trick up our sleeve. We have this layer, which is the layer we're working on, and then we have this, which is the ambient occlusion for it, or probably more like this, to be honest. But even so, now I need to put this into a compositing app or Photoshop and overlay one, multiply it over the top, blah blah blah. If I just want a quick preview in Maya, this is possible with a render layer. I go here, tick here, make sure this will be rendered to. I go up to render, render all layers, and let's make sure it's composite layers. Okay, now when I render, what will happen is it will render both. But what we'll see is first it will render the main one, then it will render the ambient occlusion, and it will put them together. But as these are both on normal, all you will see is the ambient occlusion. Because it's ambient occlusion, I'm going to multiply it. So you'll see this has now gone from normal to multiply. Other operators in here, light and dark and screen overlay. If you've played with Photoshop, you'll get the basics of this, and I'm sure we've all played with Photoshop. So now I've got this master layer, this ambient occlusion. I'm going to do a render. It's going to render both and then stick them together in this viewport, which I will do now. So you can see it starts with rendering our master layer. If you give it a second, there you go, you can see the master layer come in. And I'm going to pause now because I don't want to make you watch this blue box for the next couple of minutes, so I'll be back in a second. Okay, I thought I'd unpause here. It's finished rendering out the master layer, and now if you can see, it's rendering out the ambient occlusion layer on top, which is why it's got a render time of 18 seconds, because that's how long it took to render the AO. But it has put both of these together. If I can actually bin that and that. If I get back to a frame, okay, so there you go. There is with no ambient occlusion. There is with the ambient occlusion. You can see we've got a lot more definition around these windows, around this door, around the back of the wall here. Basically what you'd expect to see with ambient occlusion turned on. In fact, the effect is a little bit too much here, but it's fine. So that's what our render layer did for us. It allowed us to have an ambient occlusion render layer, gave us control over that ambient occlusion, allowed us to render out just ambient occlusion, or indeed to render out both together and even composite them in the Maya viewport. Okay, so that about covers it for render layer basics. I'm going to get more advanced in a little while. I just wanted to show you that you could basically create one of these render layers as a test layer. You can use it for ambient occlusion. You can use it for a lot of other things too. You can start to render all layers and even do a basic composite in the Maya viewport to make sure you're sort of on the right track. Now, before I go, there is one other benefit to these render layers. If you were to, let's say, not want a lot of this stuff in there, you could select it and hit remove selected objects, and that would take them away. And then when you did your ambient occlusion render, it wouldn't render those. So if I wanted to select those chairs, let's say, and remove them, it's just remove selected objects. The chairs will disappear, and when I do my ambient occlusion render, obviously it won't need to take the time to calculate these, because really I don't think the ambient occlusion added a lot. So it's one way that's really important for cutting down on render time. So there you go, very flexible. And I was going to cover the ambient occlusion render passes in this part too, just so I could show you the difference, but I think that's been about 20 minutes now, so I will see you back in the next part when I'll show you some of the advantages to doing your ambient occlusion, or indeed anything with the render pass, and some of the disadvantages. See you in a moment. Thanks for watching. Hi, welcome back. In the last part we looked a little bit at these render layers, what you could do with them. We set up a very simple test layer with some layer overrides so we could do test renders. We looked at changing materials in render layers and also how to set up a simple ambient occlusion layer. Now in this part I'm going to show you the same thing but with a render pass instead, and we're going to take a look at some of the advantages and disadvantages in both. So we're going to start out by creating the render pass. So under passes, and this will only be available with Mental Ray, as this doesn't work with Maya software. So start by creating a new pass and you'll get a big list here. We're going to go over some of these in some detail, others we're going to skip. So ambient occlusion, create, and just close that, and you'll see here scene passes AO. Now if you were to render right now, nothing would happen. You'd just see this. What you need to do is associate this with the layer that you're on. So if you have layers and passes work together, for instance, if I created just an empty layer and clicked on it, you'd see my AO pass has gone back into scene passes and it's not associated with this layer. This lets you create different layers with different geometries for different reasons and associate different passes with them. And we'll delve into this in much more complicated detail later. For right now I just want to show you this. So let's remove this as we're not using it. So now we've associated our ambient occlusion pass. What we need to make sure we have ticked is under features, you need to make sure this is ticked. I believe it's off by default. And if you look under indirect lighting, you'll see ambient occlusion also needs to be ticked. Now by default it's at 256, which is too high for me, so I've told it just to use 64 rays, which is what we used when we did our render layers. Now I'll take a quick render. Okay, our render is finished, and you'll notice that it's gone from 2 minutes to over 5. This was Mental Ray doing the ambient occlusion in the background, but you will notice you can't really get a sense of it. That's because it's not overlaid on the top of this image. We're not possible to do that. What we do have is the render pass here, and if I click there, any render passes we had generated would be just there. We only generated this one, so I'll pull this out and you can see it looks very dark. This is because our render passes are not gamma corrected. They don't take the benefit from the lens shader that's on the camera. So if you remember, we used a lens shader so we could have a proper linear workflow, which puts a gamma of 2.2, which this is getting, but this pass is not. So if we open the viewer again and we just bump the gamma here to 2.2, you'll see this is the occlusion pass that's been generated. Now at this point you're probably thinking that, you know, it's a lot more flexible to do ambient occlusion on a render layer, so why would I bother with passes? Why wouldn't I just use render layers? And it's a very good point. In terms of ambient occlusion, it is probably better to do it with a render layer, and this is why I picked it as a subject to show you, because render layers are still better at some things, render passes for others, but they need to be used in conjunction with each other. For instance, if I want a diffuse pass from this, if I just want the diffuse lighting information, I could go here, let's get rid of that, select everything in my scene, create a new render layer, attributes, and you'll see here, whoops, there we go, and you'll see here under presets I have a diffuse. This is only good for Maya software. Under here are the ones that work with Mental Ray, so occlusion and normal map. So unless you're doing a render that uses standard Maya materials and you're rendering with Maya software, you can only really get on one of these render layers, a very limited amount of information. Depth, occlusion, diffuse, specular, shadow don't really work when you're using GI and mental ray. They're more of an old school technique, if you like. What you can do, however, is use a combination of render passes and layers to great effect. So the first thing I want to show you how to do is break an image down using just render passes into all of its component parts. So if I just remove this layer, because we won't need it, what we'd like to do is go back to passes and unassociate this. In fact, we'll just remove it altogether. What I would like to do is get the diffuse, specular, the specular highlights, all the information that makes up the beauty pass. So we'll start by adding the beauty pass, which will give us this in a pass. We will then add diffuse, indirect illumination, so indirect. We will add specular, which would be here. We will add reflection and refraction. Okay, and that'll about do us for a basic pass. You should probably also include here a few other things, translucency for instance. I haven't because it's not used in this scene, but we'll throw it in anyway because it should be part of a standard what makes up a mental ray beauty pass. So we'll throw that in as well. Now the nice thing about this is it saves us from having tons of layers. It saves us from a lot of time as well, because mental ray actually calculates all these things in the background of its render engine. So adding all of these will not add any time to our render. You would think that with all these separate passes, if the main pass took 2.5 minutes, then each one of these, depending on how complicated it was, might add an extra minute or so. But it doesn't add any time at all. If I bring up the render, you can see here this one was 2 minutes 27. If I render again, what you should see is this one will be around 2 minutes 27. Maybe it'll be a little longer. I have some things running in the background on my PC at the moment, but it will be around the same sort of time. Certainly won't be up 5-10 minutes mark. Ambient occlusion is a little different because that's not generated by mental ray. By default, that is actually a separate process. So what you need to remember is all of these things, diffuse, indirect, refraction, specular, translucence, are actually being calculated every time an image is rendered. Mental ray just doesn't make that information available to you. All you're doing with these passes is saying, hi, I would like this information available to me. So when this is rendered out, I'll show you those different passes. Okay, this just finished, and as you see, 229, 227. So generating all of this separate information took no time at all. If we go to load render pass now, I can see just the diffuse lighting. And again, it looks dark because these passes haven't benefited from that lens shader with a gamma of 2.2. So this is just the diffuse lighting in the scene. We can take a look at the indirect lighting. So now you can start to sort of debug separate parts of your image. You can look at this indirect lighting and say, you know, I have too much bounce light in the back here, or there's not enough bounce light. It really lets you hone in on what's creating each effect within your image. It's, you know, should be an essential part of your workflow. If we look at, say, let's take a look at the specular. Okay, so you can see the specular is not actually doing a lot for us. And reflection. Again, we need that gamma of 2.2. And that's probably why we didn't see a lot on the specular, because I forgot to increase the gamma. But you can see here this floor is very reflective, probably more reflective than it actually needs to be. But instead of having to re-render now, because we have this, when we put this back together in post, we can simply mute these reflections, change our image. So let's take a look at that specular again. And there you go. You can see here where I get these very sharp specular highlights, which again makes this very easy to change in post-production once we glue it all back together. And I think just translucence, which I'm pretty sure there isn't any in this, maybe a little on the plant down here, but nothing spectacular. Okay, so this cost us no extra rendering time and gave us a great deal of information to work with in the post-production process. Now, on its own, it's a good thing. When combined with render layers, it's a great thing. What I'm going to do now is show you how to take all this information and put it back together again and tweak each individual component to radically change your image. Because now you have all this information, you of course have a great deal of control. The beauty pass, by the way, is just everything put together. So that should look pretty much exactly the same as that, which it does. Okay, remembering that again, and I can't stress this enough, because when you get these into your post-production app and you load them in, you might have a bit of a shock if you haven't realized that this has been gamma corrected, but these pass information passes do not take any notice of your lens shader, your exposure node. Yeah, so I think before we delve any further in Maya, we should duck into some form of post-production application. So I'm going to stop here. Okay, so I hope you've seen some of the difference between a render layer and a render pass. Some of the advantages of using, say, a render layer for ambient occlusion and a render pass for diffuse lighting, indirect, blah blah blah. Okay, so first we'll put this image back together, and then we'll look at how to split up each light into its own layer, and really give you a huge degree of control. Alright, thanks for watching. Hi, welcome back. In the last part we looked at splitting an image up into various different render passes, and I said I was going to show you how to put that back together and achieve a degree of control. So to get started, and this would be for Nuke, if we pop open our render settings window, you'll remember that we have the diffuse, the indirect, reflection, specular and translucence, which is quite a mouthful, and we want to get all of that information out and into Nuke. Now, when I'm using Nuke, I normally use OpenEXR. It's Nuke's native format. So go ahead and make sure you're rendering out in OpenEXR. Under Quality, I'm going to render out linear images for Nuke, which I'm going to use RGBA 4x32-bit. By default, Maya will be on RGBA 4x8-bit. So make sure you flick that over, because we want to get as much information into Nuke as we possibly can. The other thing I'm going to do is under my camera, so I'm just using the default perspective camera, I'm going to break the lens shader, because I want these images as linear. I've already used it to get the preview of what my image is going to look like, or before I start working on it in post-production, so I already know that this is the basic image that's going to come into Nuke. I no longer need that lens shader. That was just for me, so I didn't have to crank up the intensity on these lights and everything. So now I've done that, I will just change project directories to say images 6. This is just a test directory, and I'll go ahead and batch render this, which will then render this out again and create all those passes. Or you could just, file save as, but I normally work with more than one frame, so I'm just used to hitting batch render, and you'll see here result rendering with mental ray, and that will go ahead and save one EXR file with all of the pass information in it, which is one of the advantages to EXRs. If you were using a TIFF, what would happen is it would save, if you had 8 passes, it would save 8 different TIFF files, which, you know, if you have 10 passes in each and you're rendering out 500 frames, this means an awful lot of files and data to keep track of. So with this, basically we'll get, as you can see here, one EXR with all the pass information. I'm going to pause now, and I'll see you again in a minute in Nuke and show you how to put this back together again. Okay, welcome back. Here we are in Nuke. First thing I'm going to do is just go to Edit and my project settings, and I'm going to flick this to 1280 by 720, which was just my render size from Maya. I'll read in our EXR file and connect it up to the viewer. Now you'll notice it's quite dark. I've got no correction on this, so let's flick it over to sRGB, and we can now quickly take a look at our passes. There's the beauty, the diffuse, the indirect, the reflections, the refractions, the specular, the translucency, of which only this tiny part here is visible. So I'm going to flick that back to RGBA, and we're going to start getting these passes out of this EXR. Now, one of the advantages, as I think I previously mentioned with the EXR, is one file contains all the pass information. One of the disadvantages, of course, in order to edit each bit independently, is we need to get them out. So to do this, we'll just use a shuffle node. So, shuffle, make sure that this is set to what you want to shuffle out. So in this case, first things first, the diffuse. And we don't want to bring the alpha along with us, we just want the diffuse to RGB. Once again, if we hit tab, sorry, I should have said that before, it's tab to bring this up. Okay, connect this, and we're just going to start shuffling out these passes. So we did diffuse, next comes indirect, tab once again, now reflection, specular before reflection. Let's make sure all of these were set to just RGB on this side, not RGBA. Okay, and we'll shuffle out the next one. Whoops. Making sure, of course, to connect it to your EXR. So now reflection. And the next one, which will be refraction. And I believe we only have the translucency to go. Okay, now let's make sure we have these right. So this should be diffuse, indirect, specular, reflection, refraction, translucency. So that's all of our passes shuffled out. Now we need to merge them together to get back to the beauty. So I have here 6 passes, so I will be using 6 merge nodes. Okay, these have all come in hooked up. Let's just unhook them. Now, to get these together, what I want to do is go A, which will get me the first one, connect the B of this to this merge node, A, and just continue down the path. So B to the previous one, A to this one, B to the previous one, A to this one. So you'll have a chain that looks like so. Okay, you need one merge node for each pass basically. B, 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 A. You'll notice you've got a spare B here. You can use that later on to feed in a depth pass. Well, it's useful for a variety of things. We'll cover that in another part of this tutorial. So if I now go to this and hook it up, what you'll see is just the translucence, because all these merge nodes are set to over. We need them to be set to plus. So double click for Nuke. Whoops. Okay, and this gets us back to our beauty. What you will notice is in our beauty pass, if I just connect this up to the viewer, these were lit. That's because they were mental ray light surfaces, and mental ray light surfaces do not play well with render passes. You need to actually add them as a separate pass, and I'm going to show you that as well as a few other tricks for the Maya Material X in upcoming parts. But for right now, we've basically got ourselves back to our beauty pass. And the value of having all of this split is, let's say I have my indirect illumination here, but I think it's too high. Rather than going back to Maya and re-rendering, I can simply, whoops, let's click it on the right part. I can simply add a grade node in our indirect, use the multiply, and turn up the indirect illumination without interfering with anything else. I could also, of course, turn it down. So I can get this lovely control over each individual element. For instance, let's take the reflections here and grade those as well. So if I wanted to, oops, I actually don't want the gain, let's just go with multiply, have things more reflective or less. Okay, and you can see here that actually I quite like these lamps a bit more reflective, but it's also creating something I don't like with my floor and table, and we're going to get round to doing some masks later on. We're going to be using material ID passes to be able to isolate areas, but even with just this you can see straight away that I have a huge degree here of control over this image. Every part of it is basically controllable now. So let's say I wanted to pretty much crank up the overall brightness level. Here I have my diffuse illumination. Just double click. And if I multiply my diffuse illumination, you can see my brightness level goes way up. Okay, so, and that's just the brightness level of the diffuse. So I have total control over the individual elements within this scene. Now these specular highlights, for instance, I don't particularly like them, so rather than having to paint them out in Photoshop, I can just come along and turn the spec down. You know, this has saved me a ton of time in re-rendering and given me a big level of control. Now obviously I could just grade the whole thing as well. We're going to make the whole thing lighter or darker, and I can now color correct this. I can color correct any individual part. So let's say that I wanted to just color correct the diffuse illumination, which would be C, by the way, for color correct, and I wanted to change the contrast of just the shadows, let's say. Yeah, but you see that's not having an effect on our indirect illumination, it's not having an effect on our reflections or our refractions, it's simply having an effect on our diffuse illumination. So by splitting these up into their separate component parts, you'll get a much easier time of it when it comes to post-processing the image. And remember, to get all of this information out of Maya took no more time than to just get this one image out, which I could again grade, but then I could only, correct the entire thing all in one go, which is not enough control for a decent compositing. So that's how you simply split one of these things up and put it back together. In the next part, we'll look at something a little more complicated. We'll look at how you would do this for proper post-production. So what I want to delve into before we go any further is how you could do this for each light contribution. So this will allow you not only to be able to color grade and match and whatnot each individual component, i.e. the specular, the reflections, the refractions, the diffuse, the indirect illumination. This will allow you to do it for each light type independently. So for instance, sorry, I keep saying for instance, so you'll be able to turn off this light here while keeping this one on. You'll be able to turn off this light, keep this one on. It'll give you a huge degree of independence when it comes to post-production. So I'll see you in the next part when we start setting up independent lighting control. Okay, thanks for watching. Hi, welcome back. So far we've looked at render layers and render passes. We've examined the difference between the two. We've looked at creating a simple composite with an image split back into its component parts. And now I want to take that one step further by isolating each one of these lights in its own render layer. Now this will give us a degree of control in compositing, which will mean we'll actually be able to turn lights on and off. We'll be able to recolor lights for an interior or indeed for any light scenario. This is a fantastic sort of pseudo relighting technique. So we start by just creating our first render layer. So we want to select all the geometry we've got, and then we want to select which lights we want in that render layer. So for the first one, I'm actually going to use all three of these. I don't think there's any need for us to split each one of these individually because they all create sort of one homogeneous whole. So make sure I don't have the lights I don't want selected and click create new layer. Now if I did accidentally select something in here that I didn't want, you can always go into layer, memberships, and when I click layer 1 it will show me what's not there. So let's say I wanted to add in this left wall light here. You can see it's appeared. I can take it away. If I didn't want these, I can take them away. If I look under the default render layer, everything is there. Layer 1, these are missing. So, it can be a bit tricky, sometimes a bit fiddly to select stuff and then have to come back here and go remove selected objects. I find it quite a bit easier to just hit that membership thing. I can see at a glance what is in this scene, what is in this layer, and what is not. So what we've done here is let's just call this before we go any further. Just call it backroom lights. What we've done is we've isolated these. So if we take a render of this now, you'll see that only the light contribution from the backlights is coming through. And I'll just pause this a sec while that happens. Okay, as you can see, what we've done is got this back room lit and everything else has been switched off. Now I'm just going to break this apart into separate layers first. So these other three lights will each have their own render layer. So again, quite simple really. Select the geometry, the light you want. Hit. And it is quite important to keep a neat workflow, simply because when we start adding passes to this as well, we're going to be dealing with a lot of information. So, and this was right even. Okay, so if we take a look at this one now, you'll see here in our render view that we got this light here, so let's keep this. Okay, as you can see, we just have this contribution now from our right wall light. You will notice, however, these are still glowing in the background. This is because these are mere material X's with a light shader on them. And this is an example of something that will be incredibly easy to fix in post, so I'm not going to worry about that right now. I'm going to go ahead and set up this wall light left. Again, just create the layer for it and give it a name, wall light left, and keep this one. Quick test render of this. Okay, there you go, pretty much exactly what we expected, and I'm just going to do the last one, which would be this main hallway light. And this is a good example of render layers and render passes working together. At least it will be when we've finished. Okay, so I just quickly test render this as well. And I wouldn't normally do this because I know how it's going to work. I just want to flick through this render view pictures so you guys can have a look. Okay, that finished, and if we flick through now, you can see all lights on, backlight. Okay, so we've actually isolated each light from each other. I now want to set up the render passes for these, and I'm going to show you something new for that. So we'll just pop open our render settings window, and we'll create some scene passes. So once again, the order to do this in for the mere material X, but it will work with pretty much any material. This is just diffuse, indirect, specular, where have you gone? There you go. And we're going to need reflection and refraction, of course. It doesn't matter which order these go in. This is the composite in order for the mere material X is diffuse, indirect, specular, refraction, refraction, translucency, and incandescence. So what are we still missing? Translucency and incandescence. Translucence, incandescence. Create, close. Okay, so here's our passes, and what we would have to do is go in and assign these to each one. So I could go here and then start clicking away, but there is a better way. And it'll keep things neat and tidy. So what I want to do is click this, which will open a relationship editor. We want to create a new pass set. So we'll call this, let's say, main. So now we have this main set, which you can see has appeared here in our relationship editor, and we just want to check all of these and make them part of that main set. And now what I can do is just add the main set to each one. Now this is a useful feature, because if I had many passes, more than this, for extra information, I could call one main, one additional, extras, and when you flick through this, it keeps the scene neat and orderly, because when we go into contribution maps later on, this is going to get more complicated than it is now. So there we go, we have now set up each light on its own render layer with a full subset of these render passes. And you'll notice I'm not using ambient occlusion because I'm using the built-in ambient occlusion that's in the mere material X, and I'll have a run through of that in a further part when we look at some of the compositing techniques you can use with the mere material X. Okay, so now I've associated this, I will just render this so we can take a look, make sure all our pass information has come through correctly. If that's worked, which I have no doubt it will have done, we'll go into Nuke and I'll show you the way to properly composite this lot all together. Okay, so here is our render finished, and if we look there we have the full set of render passes coming from this set. So if we look at, say, the diffuse, and remember you need this gamma on 2.2 because render passes again are ignoring that lens shader that we have on there, our exposure node. You can see there is my diffuse lighting. Okay, and as I said, all the passes came through just fine. So one other thing that we're missing from this is a depth pass. Now I could put in a depth pass here by adding it either depth, camera depth, or camera depth remapped, but I prefer to do this in its own layer. So what I'm going to do is just grab here all of my geometry, create a new layer for it, call it let's see, depth, and attributes, presets, oops, there we go, presets, and you see here you've got a luminance depth. Okay, so I can hit this and this will give me a luminance depth, and if I look at the out color you'll see I've got here an out min and max on the set range. I'm going to want to change this one. If I render this now, just so you can have a look why I would change it. Okay, I got a fairly nice depth out of the box. It's not brilliant, so I'm going to break the connection here and add a new value of, let's try 2000, and I'll explain the reason why I tried 2000 in a second. Okay, that's much better, and the reason what you're looking for here is the back of the scene should be black and the front of the scene should be bright white here. The reason I tried this depth of 2000 is quite simple. If I drop into a 4 view here and I can tell my camera, let's have a look, let's pump this up, my camera is over here, say, and the back of the scene is over here. You don't need to be spot on accurate, but if I just create a measure tool, distance, so my camera is around here, back of the scene is around here, you'll see this is 14 scene units, 15 scene units, but because I'm in meters that would be 1,500 centimeters, and that's how this works. So if you wanted to get that a bit more accurate, you could drop in, I obviously knew the approximate dimensions of my scene before I picked this value. I didn't just pull it out of a hat. So if you want to come down here and change this to 1500, you might get a slightly better result. Let's have a look. Although I find it's better to sometimes oversample a bit. Yeah, that's a bit too dark for me. Like I say, I find it's better to overdo it a little bit. You could also do this in a render pass. It works pretty much the same way. I will show you just so you can take a look at how that would work. If we open up our render settings and we go to passes, we'll drop in, you can use camera depth or camera depth remapped. In this case I'll use camera depth remapped. All that happens if you use camera depth is that this value is not ticked. So, and you've got the same settings basically, near and far. So if I was to use 1800 for this, and I'll start this at 10 centimeters, and I do another quick render here, making sure that I am on a layer that we would need. So we have this set, we also now need to associate this depth remapped. If I hit render, I'll just show you what this depth map looks like as a render pass. Okay, so here we go, load render pass, depth remapped, and there you go. Now I prefer not to do it this way. Probably simply because I've always done it this way. There's nothing wrong with either way. Any way you want to do it is fine. Let's just get rid of this because we don't want extra clutter in here. And that's that. That's how to split up your scene into all of its various different lighting types and into all of its component parts. Now what I'm going to do is I'll see you in a second, and I'm going to show you how to composite this lot together in Nuke in a nice, neat, orderly workflow. So I'll see you in the next part. Thanks for watching. Okay, welcome back, and here we are in Maya. I'm going to flick to Nuke in just 1 second. I just thought it was worth to mention that in order to get these out, all of them, you make sure all of these green boxes are ticked. Make sure you have, of course, the right renderable camera, which in our case is the perspective view. We want to be on OpenEXR, and because we're going out to Nuke, I am going to use 32-bit. You could use 16-bit. 32-bit is probably a bit overkill, but I don't mind in this case. So in order to get that out, I just went to render and then batch render, and that just outputted each one of these with a green check mark. I didn't bother with the master layer as I won't be using it. Okay, into Nuke, and I just have my basic Nuke standard window open, and I'm going to read in the files. Now this is again why we named them, because we only luckily have 4 lights or 4 render layers that contain lights, but sometimes you can be working with a lot more, so without a decent naming convention you just end up with layer 1, 2, 3, 25. So I'm going to start by bringing in the main light, and you can go up here and hit this, or you can just hit R on the keyboard, whichever you find easier. So, and then I'll go wall light 1, and I don't think I have the back room lights. Okay, so these 3 we're going to plonk up here for now, as long as we have them in. And let's connect this to our viewer. Okay, let's see what its beauty pass looks like. And you're seeing this as overly gamma corrected at the moment because I forgot to disable that lens shader, which is, as I said last time, we were using that for a preview. So this is what happens. Nuke thinks this is a linear image, so it gamma corrects it, and then up here in the viewer it gamma corrects it again. That's what it actually should look like. This is not so important for us right now because we are going to be using these render passes. So if I flick this down to the diffuse, you'll see here that this doesn't have that problem. It's just this main image itself that does. Okay, so we're going to start by compositing this back into the beauty pass. Now we know that there's going to be 7 passes, so let's start by just adding 7 shuffle nodes. Okay, unhook them. And I'm going to show you a technique which means we won't have to do this with each one of these, which is why I'm just running you through this again. So let's get these connected up first. And I will rename them in a second because we will need to keep a clean workflow for this, because we're going to have many nodes. So let's start in the correct order with the diffuse. And again, you'll see here, you'll notice under your diffuse you have red, green, blue, blue twice. It's using blue as the alpha channel because these passes don't contain an alpha channel. So we don't want the output of it to be RGBA, we just want it to be RGB. Now it looks a little better. Okay, so diffuse, indirect, specular, there we are. Reflection, refraction, translucency, and incandescence. Okay, so this is basically what you did before. We can take a look at these, the diffuse lighting. That will be the, okay, I've set that to incandescence, not indirect. That's why it's always good to check. This would now be the specular. Okay. Why is that giving us problems? Probably because there is no specular highlights here. That's the reflection, the refraction, the translucence, which you won't see because we only had it on this plant, and the incandescence, which is this mere material X's additional color channel. I'll cover that in a further part. Okay, so that's basically this done. I'm going to rename these while I pause, just so you don't have to sit me watch and name a load of stuff, but we'll just put these together with a merge node now. So let's just create okay, just unhook these. It's slightly different than we did it before. I'm going to connect B here, A here, and then the same as we did before. Okay, and you'll remember that all of these are plus operations because this is how our composite goes together. And we should see exactly what we want to, which we do. This is our backroom pass. Now on that incandescence, I'm going to, let's just organize these a bit better. There we go. And one of the things I like to do before I do anything else is just add a color correction node to each one of these. Oops. So if you press C, it'll just add a color correction node. Then I'm all ready to go with these in place. So rename these, diffuse, and I think I'll just pause and do this. Okay, all I've done is just rename these diffuse, indirect, specular, reflection, refraction, translucence, and incandescence. So normally I would have just done that on camera, but I have repetitive stress injury at the moment, so my typing speed is absolutely terrible. Didn't want to make you sit through it. So okay, now we've got a nice organized layout, and as I said, this would be easy to fix in post. If we just take this incandescence and we have it here, I'm going to double click it and put the mix down to 0. That gets rid of it. So you could do this with anything you wanted. So indeed, if you wanted to nip out the specular, or say the diffuse, because it's the, there we go. So there's your control there, and obviously you have all these color corrects in place. The reason I put these in place now is because I'm going to create a special group node for this lot and actually copy and paste that group node so we can reuse it. I mean, we're only doing 4 of these, but if you were doing 12 lights, 25 lights, you know, however many lights you're doing, you really don't want to go through this whole process for every light. So the first thing we need to do is hit tab and find the group node. There we go. Okay, and you'll see what this has done. It's brought up a group 1 node graph here with an input and output. So the first thing we want to do is copy this lot, Control X to cut it, and that might take a second. Just make sure I got the cut. There we go. And then we want to paste it into there. Now connect all these up to the input. And this to the output. And what this has done, you can follow it quite simply, it's created one input up here that's all these are connected to, and one output down here that this is the final result of our composite here with these plus merges. So if I go back to the node graph now, we can have a look if that worked simply by connecting it to our EXR and then connecting it to the viewer. And there you go. If I delve back into the graph and we color correct, say, the diffuse here, so we'll just add a little gain to it, you'll see that this is actually working now in here. Now what we can do is just copy and paste this group to all of these images. The problem is that our render passes in this layer are called diffuse, perspective, view, perspective, 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 translucent. Now we're luckily enough going to be working with an image, so flick to viewer 2, that also has exactly the same names, but I'm going to show you how to deal with the situation where you want this structure, but maybe the specular pass is called spec underscore something else. So what happens then is you'd have to go in and change a lot of things. So I'm going to just show you this quickly. If you click on the group node, bring up its properties, and right click here, you can add manage user knobs. Now we're going to go to pick, and what we want to do is, and this is again a good reason to name everything properly, is take the inputs from all of our shuffle nodes. So there's the input from our diffuse, our indirect, our reflection, our refraction, translucence, incandescence, and that should be it. Yes, it is. Okay, so you see here I have in, diffuse, indirect, reflection, refraction, translucence, incandescence. So just click down, connect those all up, and done. And you can see here what we've got is in 1 is indirect, in 2 reflection, refraction, and this corresponds to these. Okay, so I can demonstrate this quite aptly by going to the diffuse. Let me just connect this to the viewer by going to, say, the diffuse and changing that to none. That will get rid of all of our diffuse light. And what that means is when we copy and paste this group node, if the diffuse on this was named differently, we would now be able to use these quick handles to just flick it to the different named paths. So let's Control C, Control V, group 2. Now we're lucky enough that all these were named the same. So when I go to group 2, this should just work. Let's connect it to the viewer and have a look. Okay, we are having a small issue there. Aha! When I was showing you our color correct node earlier, I had obviously pushed the gain up higher than it needed to be, so that was our problem. So we can actually just come back to this group now, and actually let's just delete it, and we'll just do a recopy and a repaste. Okay, and we can go in, and obviously with the copy and paste, this is why I put these color corrects in first, so they would all be flat and zero before I played about with them. But obviously because I'm as thick as the village idiot, I forgot to change it back. So there we go. Okay, so connect these other two up. So just Control V twice, and we'll just paste out those groups, and we get all these nicely arranged. And also these groups allow us, instead of having a huge node tree, we now have quite a neat little viewer here. We're not having to scroll around. Let's just check they work. So there's our hallway light, wall light, second wall light, and once again, because I've copied and pasted that that rather annoying color correction that I made, but at least gives you a chance to see that everything is working in the groups. Right, so there is this light, and there is this one. So that's the back light. So I'll probably put that start of the chain. And what I'm going to do here now is just composite these together. Okay, so I'm going to use merge nodes, obviously. Now I'm going to connect these up slightly differently. You'll notice that in these groups I connected these like this, so I used fewer merge nodes. The problem is, if I do that here, I won't be able to turn this back room light off, and I want to be able to go from pitch darkness to, you know, full illumination. So I'm going to leave the B, in this case, empty, and just add 3 more merge nodes. And again, B, A, B, A, B, A. Now, if we change these to plus operations, and hook this last one up to our viewer, you'll see here we're back to what we started with in Maya. Now, this looks all well and good. You're thinking this is a rather complicated way just to get back to where we started. But if I was to take, say, this and hit its mix, you can see I can actually turn these lights off. So let's turn this light off and this light off. And now I got a scene with just lighting from here and lighting from here. Obviously, if I grab this one, I can dim the lights in the back of the room. If I want to, I can go into the group 4 and get that incandescence and turn it up. So I have control here of my incandescence. Okay, so I have a staggering degree of control. It's even possible to animate this. In fact, it's quite easy to animate this. So I think I'll leave that here for now. Because I think what I'll do when we come back is show you how to add the depth into this, so we can do some depth of field. I'll show you how to animate this light setup. I think it's quite a nice thing to be able to do. It gives you a nice 10-second animation in no time at all. And also bearing in mind, now we have these all nice clean groups. Let's say we have this hallway light on. if you delve into its group, you have complete control over all of its diffuse reflections, refractions and all of that. But if you just want to change the group as a whole, you could hit G and put a grade node in here and start tweaking the whole group for just that one light. Hi, welcome back. In the last part we looked at creating these Nuke groups so we could store our separate passes in there. I haven't really changed anything. I've color corrected this a little bit just because it was at different levels, and if you go into Backroom you can see how I've done that, just with the radial mask on this one, which was a little bit too light. I won't go into it, but I will provide the scene file. You can see it yourself. It's very simple. So we're at the stage now where we've got this ability to turn things on and off on a per light basis. And what I wanted to do in this part was just add a depth layer, and if you notice I've got the spare B hanging around. This is going to be to connect my depth layer to. I did change this as well. I just put a color correct under each one so I could use the gain to switch things down and on and off. You can also do that with the mix, but it's probably better to do it with a color correct. So let's first off look at getting our depth layer in here. So let's read in the file and depth. Okay, here is our here is our depth layer. So I'll just connect this to B, and if I connect this to the camera you'll see that this is a standard RGB image. If I have a look under depth, nothing there. What we need to do is shuffle out that depth and then shuffle it in to, well, it's actually easier to show you. So I'm going to tab and shuffle. Going to shuffle out the RGB and I'm going to shuffle that in to depth. That way when I connect this to this and connect this to our viewer, set our viewer to depth, we should have one, but for some reason we do not, because I have hooked that up to the wrong thing. There we go, there's the depth layer. So now we can use this depth layer to do a sort of pseudo 2D depth of field. 3D depth of field, in my opinion, normally looks a little better, but it can take an awfully long time to calculate. So this is, in most cases, how it's done. So let's take this viewer off depth and just go back to RGBA. Now we've got all of these because we've arranged them nicely in this graph. All we need to do is connect a Z depth here, because we know, a Z blur, sorry, because we know that this depth channel has shuffled all the way through this lot and made it to the end. So let's just try for Z blur. Okay, whack that in there. And you'll see the whole thing has gone slightly blurry. So if I click on this, we can sort that out. I get a focal plane set up. Now what this will allow you to do is focus in your image. So let's say I want to make this my focal point. What I would do is grab this focal plane set up, and probably that's enough. Let's undo the focal plane setup. Okay, you can see this is in very sharp focus and this is ever so slightly blurry. If I increase the size, you can see that blur in the background there. Okay, and sort of to enhance the focal point, I can bring in this depth of field as well as another indication of where I'd like it to be. So I mean, there we go, perfect. Okay, and now I have a monstrously huge blur here, too much. But anyway, I think you get the basic gist of this. I don't want to make this too much about Nuke, although, you know, when you're doing these render layers and passes, you do need something to put them back together again. but I just wanted to show you that our depth of field pass, our depth pass, did indeed work. As you can see, it does. The other thing I wanted to show you just quickly was how you could actually animate these lights within Nuke without having to render. If we go up and give ourselves 250 frames, which at 25 frames a second, whoops, wrong one, is 10 seconds of course. So I'll go here and go 250. Okay, you'll see our slider here has changed to 250. Now, if I want to animate these lights, I can just whack the gain on all of them down. So we'll start, say, with all the lights off. Okay, and the reason I would do this is basically just to show off the lighting, various control I have on the lighting. It's just kind of a funny thing to do, to show off your image if you don't just want to show people a still. But anyway, as I said, I didn't want to make this too much about Nuke, so I think we'll start here and key this gain, which in Nuke is quite easy. You just set a key, and I'll key this up to 1, and it auto keys after you've set the first key. So if we actually play that back, you will see. And thing to note, the reason it's very slow is because it's calculating this Z blur. So if you click that and hit D, it will disable the Z blur while we do this preview. And there you go, that's that light animated on. Okay, so now it really is just a simple case of deciding where you'd like everything else. So if we turn on, say, this hallway light, and you can do this in any order of course, and we key its gain and we turn that on over, let's say go to 75, turn that on. Okay, let's let people admire that particular light and scenario for a moment, and then we can use this left light here. Once again, set the key on the gain. We'll turn this one on fairly quickly. Okay, that's our left light popped on, and we'll go straight to the right light, and we'll start this at frame 150 and finish it at frame 200. There we go. And then just to show that we can, and why not, at frame, let's say 180, we'll set a key here to make sure it's on 1, and then we'll go here, let's say frame 210, and turn it off. But this is a nice way to just show off your lighting, let people see how much control you have over it, and you know, you can use this to animate going from daytime to evening and whatnot with 1 frame. Well, in our case 4, 1 for each light. Let's play that back. And there you go, it really is that simple. So just, and you know, I haven't delved into to even tweaking all the stuff I could with the control that I have. I didn't want to spend half an hour in Nuke, or a couple of hours even, might take even longer than that. I just wanted to show you the basics so you could see the advantages in rendering out your image this way. And all of these diffuse, indirect, specular, reflection, refraction, translucence, incandescence add nothing to your render time to calculate. So if you can do this, why not? Okay, in the next part I'm going to come back and talk about contribution maps. Thanks for watching. Hi, welcome back. In this part I want to go over contribution maps with you, which you'll find are just quite a fancy masking system. So what I mean by this is, in the last part we created a render layer for each light in the scene, which gave us this control in Nuke to be able to turn each light on and off, and we also be able to control the specular of each light, the translucence, the refraction, and so on and so forth. What I'd like to discuss now, though, is if I have this image here, and I have these tables and chairs in the background, or this wooden balcony, and I'm not happy with this, I think it's, say, far too dark, and I want to change that, well, of course, an easy way to do it would be to increase the gain on the hallway light, let's say, and this will get lighter, and this to a certain extent, and then if I increase the gain in the, let's say, back room, click the right node, helps a lot. So I increase the gain in the back room, these tables and chairs get a bit lighter, but I can't really just do the tables and chairs. In order to do that traditionally, or in a lot of cases, I would just create a mask for these objects and then mask it off in Nuke and change just this. But then I would lose that ability to control the individual elements of this, the diffuse lighting, the all the passes that we normally do. So what I want to show you in Maya now is what they call a contribution map, which will allow me to do these really fancy masks but still keep all of the control. Now I'm going to do this on the master layer. If you open the scene file with all the individual layers, you can do this for each layer. You can do this for as many layers as you want. I'm just going to do it on one because I want to show you the technique as opposed to running through the whole process, because it will just be me doing the same thing 5 times in a row. So I'm going to try and avoid that where possible. A little repetition is not always unavoidable. But anyway, so we're going to start by creating a contribution map for these tables and chairs. And what this is going to let us do is have one scene and then this as a separate object. So rather than me waffling on about it, let me just do it. So there's the tables and chairs, select them, and this is kind of like creating a new layer. It's basically creating a layer inside a layer. So select the objects you want in the layer, click Pass Contribution Maps, create Pass Contribution Maps and add selected. Now you'll see here, I'm going to actually name this chairs, would be a sensible thing. So now we've got this layer and we've got this sort of layer within a layer. Now we need to add some passes to this. And again, it's important to keep these naming conventions, because you saw in Nuke how many things that we had. So if you don't do this, then when you use contribution maps, it's going to be a huge mess. You'll have all the layers, all the passes, all the contribution maps, and if they're not explicitly named, you're going to run into trouble. So let's, for this contribution map, just throw in a beauty pass, just so I can show you what I'm on about. And I always give these pass prefixes, because we'll be creating a lot of passes during this process. So I'd already done this before I started this tutorial, so I created a pass prefix called chairs. Don't need a pass set. So I've got a chairs beauty pass. I need to throw it into the associated passes and throw it in to the associated pass contribution map, which is called chairs, obviously. And I'll render this out so you can see what I'm talking about. I find it probably easier if I just show you rather than trying to explain it, because I do tend to waffle on a bit when I go into tutorial mode. I apologise for that, Mr. States the Bleed Novice. Anyway, I'll be back in a moment. Okay, that finished rendering, and again, with adding any render passes, even if you add hundreds of them and use complicated contribution maps, it won't add any time to your render. A couple of seconds maybe, but So I'm going to open this chairs beauty. I'm going to remember we need the gamma at 2.2, and there you go. I have these chairs on their own, completely isolated, just the beauty pass. But that means if I can do that with the beauty pass, I could add all of the passes, then add the rest of the scene to another contribution map, and I'd have a situation where I could actually control this and the environment around it as separate objects, even though they're in the same scene. So what I'm going to do is I'm just going to show you this. It can be a bit confusing the first time you do it. So I'm going to get rid of that. We're going to add the passes in properly. We're going to add the contribution maps properly. So if I'm looking at the scene, a few things I might want to control is the environment, so the walls in the room. So if I take front room, the lamps for instance, these, as I said before, I believe in a previous part, this would be really nice to be able to control the reflectivity on these. So I'm going to get these golden objects, and I'm also going to take this light switch and I'm going to add those to their own contribution map. This will give me control of shiny objects, you know, these, so I'll have some control for that. So again, pass contribution, here we go, create and add selected. Let's call this, just call this gold. As long as you know what it is, that's okay. If you're working with other people though, it might be an idea to actually give these more descriptive names. So, and I'm going to take the walls, main house, which is pretty much everything other than a few knickknacks, and what I don't want in there is the balcony. So I'm going to find where I put that. In fact, what I'll do is I'll just take this, and that pretty much makes up our environment. So I'm going to add a new contribution map. Okay, I'll just call this one env. Okay, so now if we look at what we have selected, we have the chairs, we have the environment, and we have these objects with this golden color. Now we need to add in the rest, so what I'm going to do is I will go here and select this window detailing, coving, skirting boards, and this is all our sort of white gloss paint, so that can actually get its own pass contribution. Whoops. And I'll call this gloss paint. Okay, I think that got it all. It did. Okay, so now we have the chairs, the main environment, the gloss paint, the gold. What we're missing right now is our plant, our stairs. So I'm going to do the stairs as one as well. Stairs. So as you can see, you can really break your scene down. I mean, you could even add each object into a pass contribution. It would be overkill, but you could do it. Wouldn't add anything to your render time, and you're going to get this great ability to control this scene. So let's see, let's add anything else I might have missed. I don't think I got this plant. I did not get this foot railing, and I did not get this wall sculpt. I didn't get the sockets down here, and I missed the backroom lamp. Now I'm just going to put this into a miscellaneous group. I'm not really going to need to control this. If I did, obviously I'd split it further, but I don't want to go too mad. So we'll just call this one MISC. Okay, so that's our scenes split up into pass contribution maps, and like I said, if you had each light split up into its own render layer, you could just do this with each render layer as well. Now we need to create the passes for these, and that's not quite as simple as creating one group of passes. You need to create a group of passes for each one of these. So let's open our render view here and start adding some passes. So what I'll do is go for the standard way to composite, so I'll need diffuse, indirect, refraction, specular, translucence, and irradiance. Now this is going to be for the chairs pass, so it's important to prefix these. You'll see why in a minute. So create and close, and I've got, there's my chairs. Okay, and now I need one for my env. It doesn't matter where you selected these, we're just adding them up here. I was just pointing out for some reason the env was spelled ENV. I'm not sure why I was doing that. Like I say, I tend to go a bit into Captain Obvious mode when I do a tutorial. So let's grab these again. So we want once more diffuse, indirect, incandescence, reflection, refraction, specular, and I'm going to now preset this ENV. Create and close. And I'm just going to do this. I'm going to add all 7 of these in for each one. I'm going to pause the video now, and I'll be back when I've done this, so you're not spending all your time just watching me create these 7 same render passes over and over again. So I'll see you in a second. Okay, so I've just finished adding the passes, the same as I did for the first 2, and now you can see why we needed those prefixes. So I've got chairs. All I did was added a beauty as well. I forgot it when I did it when I was on camera. There's the environment, the gloss, the gold, the misc, the stairs. Okay, so associate that lot after you've created them. Come down here to your associated pass contribution maps, and we're on chairs, so let's associate all the chairs. Let's go to env, associate all the env, gloss paint, associate the gloss, gold, associate the gold, misc, and finally the stairs. Okay, so what we've done now is we've split our scene up into 6 disparate elements. Instead of 6 different lights, we've actually created sort of 6 complicated masks, the environment as a whole. I'm just going to do a render so we can take a look at some of these, and I'll show you another trick, especially when it comes to having a contribution map for an environment, so Mental Ray can actually, well, better to show you. Back in a minute. Okay, our render is done, and this is what I wanted to show you. If we look at our render pass and list, now we have 48 separate passes, and even with 48 separate passes, our render time only increased by about 30 seconds. This is because all these are generated by Mental Ray anyway. It's just had to split them up, so it's had to do a bit of extra work, but not much. But if we take a look at the environment beauty pass, there we go. What you'll notice is, if I increase this gamma, there's black holes. And this is fine normally because we're going to put other things over the top. But for an environment pass, I like to tell Mental Ray to actually render through this. So, because Mental Ray normally doesn't render behind stuff, it would be a waste of time. But in this case, just in case I need that information, I'm going to tell Mental Ray to get on and render straight through all of these objects here. So you'll probably never need it, but you should be aware that its function is there in case you do. It would be handy if I, say, wanted to make these chairs semi-transparent in post. Why I would, I've no idea, but point is that I could. Maybe if I had a glass decorative object on here and I wanted to make it semi-transparent in post. Right, so bring up your render view, go to your env passes, and we're we're going to need to edit this. So there we go. Just double click it and it will bring up the end beauty. And if I click hold out, this will tell, and I need to do this for each one of these passes. This will have mental ray render right through. I'll show you what I mean in a second. Missed the spec there, I think. Okay. Just make sure I got them all. I did, and I will see you again in 3 minutes, and I'll show you what I mean with this hold out. Okay, welcome back. I'll show you what unticking this holdout did for us. And I like to do this with the environment sometimes because, like I say, if I did want to make these semi-transparent, these tables and chairs, or if I wanted to make this semi-transparent, or basically I'd need to know what was behind it, and when this holdout is ticked, it just registers as black space, nothing. So if we bring up that pass now, I'll just use the beauty, it's probably easiest. And I put the gamma to 2.2. You can see now, because none of this was in our environment, that's the wrong one, it's rendered straight through it. The same with the tables and chairs and the lamp, it's just rendered right through them. So now, if we put those tables and chairs back, and you were, for whatever reason, to say make a glass tabletop, it would work, because it can see the background. So, not a function you're going to use all the time, but definitely something you should be aware of, just this holdout thing. And you can do that with every pass if you want to. I rarely see the need, other than a background environment sort of contribution. So, you know, this is contribution maps, really. It's just a really great, fancy way of doing masks. It's a lot more flexible than a traditional material ID pass. It takes a little more time to set up. And I'm going to leave you now. I think that's pretty much covered the basics of pass contribution maps. I'm going to take it into Nuke, and I'll see you in Nuke, and we're going to put it all back together again. Okay, so I will see you in the next part when you can join me in Nuke, hopefully, and see what control we now have. Thanks for watching. Hi, welcome back. In the last part we created these pass contribution maps. Before we go any further, there is one thing I should tell you. When we created our environment pass contribution, what I'd done is I'd forgot to add these to it. So all you need to do to fix that, if you're following along, is simply select these in the viewport and hit add selected objects. It's as simple as that. Okay, now we're going to go into Nuke, and I'm going to show you the workflow to put all this back together again. It is pretty similar to what we did when we put the different render layers together, because this is just sort of a render layer with a lot of sub render layers, but the workflow is slightly different. So I'm going to pop that open, and hopefully you'll be able to follow along with this. So first of all, read in our EXR file, and this is again when EXR files become a real benefit, because we have in this, I believe, 48 passes. Let's just wait for that to load in. Sorry, computer's a bit slow. Yeah, we have here 48 different passes. So if we were doing this normally, you would have to open up 48 different files. Now, before, when we did the individual light render layers, that would have given us 4 images, all with 48 passes, so 192 passes. We already in this simple scene would have been on 192 images just to get these passes in. So EXRs, when you're working like this, are a godsend. Right, without any further ado, we know we have a beauty pass, a diffuse, an indirect, specular, reflection, refraction, translucency, and incandescence. So 7 passes we should have. So I'm just going to whack out 7 shuffle nodes. Okay. And you've seen this is it's almost exactly the same workflow we used before to get these passes out. There is one minor difference in this time around. We need to bring forth the alpha channel as well. So I'll just hook all these up. They don't have to be hooked up in order, obviously. I just have some sort of OCD. Okay, and then start pulling out your individual passes. So we're not going to use the beauty pass for anything but the alpha, so I'll put that in the end. So we'll go with the environment first. This is diffuse environment, and now you can see why it becomes particularly important to start naming stuff, because if this was all random, 66714, you'd be here for a month of Sundays. So diffuse environment to RGB. Okay, and the order is indirect. You should do next. So what you're looking for is indirect environment, RGB. And you might remember in the last Nuke lesson we had, I showed you how to create custom user knobs for groups that we didn't really need. Well, now we're really going to need them, so hopefully you'll see why I did that now. And I'm just going to keep shuffling these out. And specular, of course. So environment specular. And I mean, this does seem like a bit of work, but when you're not doing it and talking at the same time, you can get this done really quite quickly. And I'm just looking obviously for the incandescence. Okay, so that's our basic passes shuffled out. Now before I merge these together, I'm just going to rename them because we'll have one of these for each of our individual contribution maps. So again, it becomes important to keep a clean workflow. And I'll pause this while I do. Okay, so that's all those named up now. Let's just join them together. So we have 7 of these, so we'll use 6 merge nodes. Okay, and this workflow for compositing these passes should be pretty familiar to you now. I'll run through it once more just in case you missed it. It doesn't take a second. So background, foreground, background, foreground, background, foreground, background, foreground, whoops, background, foreground, background, foreground. Now, as I'm going to be grouping this and then copying and paste it, what I would like to do is put the color correction nodes in first, so every time I copy and paste this I don't have to go and do it again. So I'm just going to hit C on all of these, which will add a color correct. Obviously you will use more than just color correct, but I find I pretty much always use color correct, so I'll stick them in there. If I don't use them, it's not a problem. So if we connect this now to our viewer, what you will see, of course, is absolutely nothing, because these are all over operations, and the correct way to composite these together is with a pass operation. A plus, sorry, not a pass. Okay, and there is our environment in. Now, there is one extra thing we need to bring forward, which is the alpha channel of the environment. And this is fairly simple. All we need to do is create a shuffle node, bring it after this last one here, plug it in. And what we're looking for is in is RGB, which is perfect because what we want is this. In 2 can be the environment beauty, because that's the one that contains the alpha. and here we want to set this to alpha, and here we want to set it to alpha. So if I connect this to the viewer, you'll see that nothing is changed, but if I go now and look at our alpha channel, you can see that this actually doesn't have one. It wouldn't do because it's full up, but we're going to need that later on for the other passes that do have an alpha channel. So let me just rename this. Big A for alpha. Okay, and you'll be glad to know that even though we have, I don't know how many it was, 6 I think, yeah, 6 of these contribution mats, that's the last time we're going to have to do that. So create a group node. There we go. And you'll see it's brought it up here, group node 1 graph. If you remember, if you double click it, you can also find it under S there. So let's copy this lot, or in this case cut it, and let's paste it here. And I'm sure you remember, but these go to the input. And this one to the output. I seem to have brought the viewer along with me for some reason. There we go, didn't need it. Okay, perfect. So now this is all grouped up nicely. If we go back to our node graph, I stick that in there, there we go. So similar workflow to we used before. This time we're just bringing forward the alpha, and I'll do the same thing I did before by hitting manage user knobs, pick, and again you'll see now why naming is again important. I hate to keep beating you over the head with it, but I've had so many files from people when you just open them and it's just a huge mess. So we want to pick in from the diffuse shuffle the in node, which would actually be the diffuse in node for this contribution map, and we want to just repeat that process with the indirect, the spec, reflection, refraction, translucence, and for the alpha you actually want to pick 2. If you remember, that's where you link the beauty pass up to, so not in 1, in 2. Okay, let's make sure we got everything. Alpha, incandescent. Yeah, that's everything. Okay. Now make sure these are in the right order. If they're not, you can push them up and down. But this is the order I want them in. This is the order they're composited in. So that is good. And hit done. Right, the reason you did this, last time we didn't actually use it. We did it, I do it as a matter of course. But last time what we did was we copied this group and pasted this group, and then we connected it to another image. And this had the same names in the other image. This time we're connecting it to the same image. So now what happens is if we do this, we'll see the same thing, of course. Now you could go into this group node and come here and say, no, 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 this is not the environment diffuse, this is now, say, the gloss diffuse. But it does become a lot easier, now we've created these, to just go environment, gloss. So you can see it's quite a bit easier once you create these user knobs for yourself, and they're not that difficult to create. In fact, they're very easy to create. So we'll make sure these are all set on gloss now. And okay, so you can see our contribution map that we did for the gloss paint, and now you know we've got this as well. So here's all the diffuse, you know, all the passes for just the gloss paint. So we've already broken this up into the main environment and this gloss paintwork, which in of itself I think is a great start, because you know you often see these environments, paintworks are slightly too glossy, you end up re-rendering, and then you take some spec off here, but it takes it out on, say, something like the table, which is why we've gone to the trouble of creating these things. So I'll just bring in a merge node so you can see this whole thing together. And there is our gloss paintwork with our environment. Okay, so you know, once you start getting the hang of this, in order to bring a different contribution map in, I just now need to control C and V, hook it up to here, and let's put in, let's say, the stairs. So let's go for stairs, and stairs, and stairs. Brain freeze, sorry about that. Okay, so let's have a look at our stairs. There we go. Let's connect that up. So let's hit M on the keyboard for a merge node. Background, foreground, connect it up to the viewer. Actually just hit 1. Okay, there's our stairs in. So we start building up these this image from these layers that we've done. You will notice that another reason I wanted to walk you through this is because all of our previous merge nodes have been plus operations, because the diffuse plus the indirect plus the spec plus the reflection plus all these other things make up the final image, or in this case the final contribution map. In this case, because these are being overlaid on top of each other, it's not the stairs plus the background, it's the stairs over the background. So that's why we're using these over operations. Okay, let's add our other 3 contribution maps in here. So we need to hook the group node up to that, of course. And we still need the chairs, so let's do the chairs. Which would be somewhere, indirect chairs, there we go. Let's take a look at that, make sure we got our chairs back. There is our chairs. So once again, merge this, leaving it on over, background, foreground, out to the viewer, and there's our chairs back in the scene. And just keep going really, just till you've got all your contribution maps in. Remembering to connect the group up to the image. So we've done chairs environment. Let's do the golden materials. There we go, all gold. And if any of you have been following along with this and you've sort of gone, that's alright, I'll name things later on, well, now you know that it's probably better to do it from the beginning. Okay, background, foreground, and this should bring in our gold items here and here. So we'll be able to control all the reflection and refraction and whatnot from just these items. Okay, should be one more. So let's get that in. Whoops. Okay, connect that to our image and let's have a look at what we are missing. We are missing the misc. So indirect, yep. Okay, let's just make sure we got all that MISC stuff. We did. And you can see now, if I flick to alpha, that the alpha channel that we created earlier is actually working. So, and there is all the stuff we assigned in the MISC group. So one last merge node. There we go. BA. Okay, so I have the environment, the gloss paint, the stairs. That's what's missing. A fairly major part of the scene. Gone a walkabout there. So there you go. We've now got the same image we got out of Maya. If you're wondering why there's a black line here, it's because if I look in Maya, there's actually a piece of geometry there in the corner. If I can just snag it, there it is, that I forgot to include in our environment pass contribution map. But again, that wouldn't really be a problem. I could just select it, hit add selected objects. Okay, I'll go back to my bookmark camera view, and if I render this again, all I need to do is go to Nuke here, double click this and hit reload. So it's a bit of a pain, but we know why it's missing. It's just a piece of geometry that didn't get into the contribution map. Okay, so now we've got all of these groups, so each group comes with its, massive degree of control. So rather than a simple mask, if I was working on, let's say, these tables and chairs with a simple mask, what I'd be able to do is just sort of mask them off, make them slightly lighter, slightly brighter, but instead I have a lot more control than that. I have control over all of these elements. So let's take, for instance, the indirect illumination. I can take the color correct on it, increase, say, the gain, so I can lighten up just my table and chairs without affecting anything else within the image. I could take the direct illumination and increase the gain on that and make it a lot brighter table. But then if I'd have done this with a mask, now what I would find is this far too reflective, and I'd be scuppered. I'd be hand painting in Photoshop, or I'd be spending ages. What I can do instead is just select here the reflections, grab the color correct and turn the gain down. There we go. So you see there's up, down. So I have a huge degree of control over this. Now if you take something like all the gloss work that we put into one contribution map, there we go, so that's under graph node 2, and I actually wanted to change the color of it. I can use something like a hue shift. It's not going to be subtle, but so I'll just hit tab and hue shift. There we go. Can plug it in just here, and if I were to do a hue rotation now, you can see here that I can radically adjust the color of the gloss work there. And as I say, you could do this with a mask, but what you couldn't do with a mask is then go, don't like that specular highlight, let's take the contrast on the highlights, say, okay, let's just do it globally, and there we go. I can sort of smooth out that speck there. The same with this one here. So, once you've got this broken down, I'm not going to run through each tiny little composite I would do, but once you've actually broken this down, you actually have, masks, but masks plus, if you like. The same thing is possible if I take our environment, for instance, and I start messing around with, let's say, the diffuse. I can now just correct the environment. Okay, so that's how you put a pass contribution map back together again, and by assigning these user knobs to these groups, it becomes very quick. I mean, we put together 48 passes here in, I would say, probably 15 minutes I think I've been chatting away to you for, and that's including the chatting. So once you get into this sort of workflow, you just becomes the normal way of doing it. It gives you, so much precision in your masks and in how you want to split your image up and whatnot. And if we'd done this over several images now, we'd have control of the lights, we'd have control of pretty much everything on an almost material level, to a certain degree, of course. Okay, so in the next part I am going to come back and talk about some of the things you can get out of the Maya Material X. I'm also going to come back and talk about standard sort of masks, so how you do a quick mask. So if you don't need a fancy pass contribution map and you just want to mask, say, this thing here, I'll be showing you how to do that. It's sometimes referred to as a material ID pass. And we'll also take a quick look at controlling shadows. Now, I don't particularly like to control my shadows, which I know sounds a bit strange, but what I like to do as opposed to this is, I'm just going to save this and open up the old Nuke scene we had. Okay, what I actually like to do, as opposed to trying to sort of fake shadows, is, hang on, let's open this. It's to do what we did before, which is basically separate out all these lights. Let's disable this Z blur. And I mean, shadows are a product of light, so if we look at this one here, if I turn this light down, so, and this is just the file we put together before, you'll see the shadow gets darker as you would expect. If I turn this hallway light up, hang on, once again, if I turn this hallway light up, this shadow will get more pronounced, as you would expect. So I find that by separating these lights out into their own render layers and then using them this way, I get the control I'm looking for on my shadows, and it tends to be a lot more realistic. However, there are times when you will need to fake the odd shadow or two. So we'll discuss how to output from the Maya Material X for that. We'll also discuss sort of standard mattes and any other miscellaneous information I might have forgotten to cover. Alright, so I'll see you in the last and in the next part, and hopefully the final one. Thanks for watching. Hi, welcome back. In the last couple of parts we've taken a look at past contribution maps and how to put them back together within Nuke. In this part I'd like to talk about getting even more control over your materials. Now, I did mention that we'd take a look at how to fake these shadows, how to lighten them up and darken them up, and in order to do that we're going to have to look at a different way of compositing this Maya material back together again. Now, I'm using the architectural material for this specifically because this is what it was designed for. It is a great material, and I'm going to show you now an even more complicated way to break it apart and put it back together. Now, it might seem like quite a bit of work, but depending on how long you've been modeling and texturing your scene, it can be well worth it if you need that extra degree of precision when it comes to post-production, when it comes to compositing it all back together. So I'm going to pop open Maya here, and here's where we left Maya with these past contributions under the master layer. And what I'd like to do first of all is show you how to do the trick with shadows. Now, in order to do this, we're going to need a diffuse level and a diffuse raw, which if you look under passes, they're actually not in the standard pass list. So this is going to require a bit of work on our part to get these out again. So as we've split this scene down into past contributions, I'm just going to do the environment. I'll leave it to you to do the others, because as you'll see in a second, this is quite an involved process. So if I pop open the hypershade, the first thing we need to do is get those diffuse level and diffuse raw out of our materials. So I'll work on the whole pass at once. What I'll actually do is go here and select objects in the pass contribution map. Then I'll graph the materials on those objects. So just graph materials on selected objects, and this gives me all of the materials in that one pass contribution. There we go. So this is a bit of a mess. What I'd like to do is clean this up a bit. So I'm just going to go to output connections. Actually, there we go. Flip back to previous graph. Right, I need to select all of these before I do that. Otherwise, as you can see, they just disappear. There we go. Right. Okay, and that makes it slightly easier for us to work here, so I can pull these out. Bit less clutter now. Okay, and now to get the diffuse level and diffuse raw, we need to use, under miscellaneous, under mental ray, we need to use one of these right to color buffer nodes. And actually we need one node for each diffuse level, each diffuse raw for each material. So as you can see, we need two of these for each one of these materials. Let's just space these out a bit. Now, as I said, this can be quite an involved process, but it will lead to just about the greatest degree of control you're going to get. So it can be well worth it if you have a scene that perhaps needs quite a bit of tweaking. And once you've done this a few times, it does get a lot faster. So I'm just creating two of these for each of our nodes, and let's make this a bit bigger. There we go. And now we need to get the diffuse level and diffuse raw out of this. So if I middle mouse drag this onto a right to color buffer, select other, you'll see here, these are all the outputs you can have from the Maya Material X, which is one of the reasons it's such a great material to use. As we've discussed before, you can get a lot of outputs from this. So I'm just going to pick the diffuse level into the color of this right to color buffer. So I'm going to just drag this again and go other, and this time I'm going to do diffuse raw to color. So this material is now outputting its diffuse level and its diffuse raw. I'm just going to do the others exactly the same way. Diffuse level, color, other, diffuse raw, color, and the same. As you can see, this doesn't actually take too long. It is a bit of a boring, repetitive task, but okay, so that's all of those done. Each one of these now is writing out to a custom color buffer its diffuse level and diffuse raw. And when we take this into Nuke later on, or indeed any compositing app, we can multiply those together to get the actual diffuse. But because we have both the raw and the level, it gives us more control over what we can do with them. The other thing is, if I were to just let's say render this now, nothing would happen because these are not writing to anything. They're receiving the data from, but they're not going to anywhere. So in order to do that, we need to create our own custom passes. So if you pop open the render tab, and what we'll do here is create a new render pass, and we'll call it env level, and custom color is what we'll use. So now you see I have this env level custom color, and I'm actually going to just rename that because I don't want this custom color. And once again, naming conventions become important simply because we're creating even more passes now for Nuke, so you don't want to pop this thing open and not know what you're looking at. Okay, so we have this env level. What we need to do is just associate it with the pass that we want it in. So let's pop it down into associated passes first, and then env level, there it is, and then pop that into the contribution map you're working with, or indeed if you're not working with a contribution map you don't need to bother with this, but I'll just pop mine in there. So now I have an env level, and I need to do the same thing for environment raw, so another custom color. Just call this one env raw, rather unimaginatively, and nip off that custom color. Okay, once again into the associated passes, into the contribution map. Okay, now when I render, we'll have two other render passes, or at least we would. Sorry, I skipped a step there in my haste. If you click on these custom write to color buffer nodes, you'll see here color pass. Now we need to take all the levels, which I put on the left hand side for all of them. Double check that, yes I did. Okay, great. So we need to take all of these ones that are output in the diffuse level and put it on level. And that will then write this information to that render pass. Okay, and just do the same with the raw, of course. Okay, and that should be all of them. Let me just check. Yes, 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 yes. Okay, so what we've just basically done is told this Maya material, or all six of these Maya materials, to output their diffuse level and diffuse raw into a write to color data node, and then we've told the write to color data node to output those to an env level render pass and an env raw render pass. So I'll be back in a second after I've just rendered this out. Okay, let's start the render. See you in a second. Okay, welcome back. Our render is finished, so I'm going to jump into Nuke. I'm going to reload this image. Okay, and you see it won't actually change. This is simply because we haven't hooked up any of those passes yet. But let's take a quick look at them, shall we? So we should see now env level. There we go. And env raw. Right, now obviously these two are no good to us as they stand. What we need to do is go and open our environment group here. We need to disconnect the diffuse from our environment, and before I do that I'm actually going to flick the camera back to just RGBA. Let's connect up our final node here. Okay, so we're not going to be using this because we're going to replace it with that diffuse level and diffuse raw. So the first thing we need to do is grab a couple of shuffle nodes, and as we've done before, we need to shuffle those passes out. So I'll connect them up to the group input, which is, as you know, connected up to the image itself. Okay. and let's bring out the diffuse level. So here we go, env level. I actually should say diffuse level. That's my naming mistake there. It's not terribly important as long as you know what it is. What is important, however, is when you render this out of Maya, you're probably going to hand it over to a compositor if you're working in a more production environment. So, you know, try and keep this neat for them, because it does get confusing with all these passes. Okay, so I'll just name these diff level and diff raw. Okay, what we need to do with these is multiply them together. So I'm going to input another merge node. Just hit M on the key. Helps if you hit the right button. M on the keyboard. Okay, let's just move this color correct down. And I'm just going to go A, B, and instead of over or plus that we've used before, I'm going to use a multiply. Okay, and now I need to connect this back to this one here. So what you should see is we've got exactly the same as we had when we were just using this diffuse. But now, because we have the level and the raw, if I take raw and grade it and then hit its black point, I can actually have control over these shadows in the environment now. So I've got a greater degree of control. So doing it this way is sometimes more beneficial than doing it this way. It depends how much control you actually need. It does actually get more complicated than this, which I'm going to show you now, which will get even more options for this diffuse. What we're going to need for that is we're going to need to do the indirect raw and the ambient occlusion raw, which is all going to join together. And this is also the correct way to apply ambient occlusion. What most people do, and in fact I'm guilty of this myself, is they take the whole image and then they multiply the ambient occlusion over the top of it. This is actually the incorrect way to do it. And as I say, I am guilty of doing it this way. It does work. It doesn't, however, give you the best results. I'm now going to nip back into Maya. We're going to write out the same way we did with these when we wrote out the diffuse level and the diffuse raw. We're now going to write out an indirect raw and an ambient occlusion raw. So back into Maya. If we open up our hypershade, we should still have all of our connections here. And we're going to need two more of these, as I say, for the ambient occlusion raw and the indirect raw. So let's go ahead and add two more. As you can see, this workflow is quite a bit more complicated than the standard render pass workflow, but again, it does give you that greater degree, or should I say, it gives you more options in the post-production process. Okay, and basically this is going to be the same thing, except we're going to now write out indirect raw. So let's find the indirect raw and connect that to the color. And we're going to do the same with the AO raw connected to color. So each one of these is basically just having an indirect raw and an ambient occlusion raw written out to it. And if you were doing this, we're just doing this for one of our contribution maps, but if you were doing it for the whole scene, obviously you'd need to do this for every material. It is, well, I wouldn't say time consuming. I mean, if you compare it to a UV mapping or modeling or the texturing process itself, this is really quite simple. sure. Sorry, forgot where I was there for a second. Okay, there we go. Whoops. Okay, let's hook those up, but once again they're having data written to them, but no data is going from them. So let's just pop open our render settings window here and create another couple of custom color passes. Excuse me. So custom color, and this time it's going to be env. Let's do the AO raw. Okay, and just rename this. If these are too long, I think it's 36 characters, more than 36 characters, it will truncate them and you will end up with passes named env AO 982864. Maya will just give them an ID. And as we've seen, when we're in Nuke, we do need that naming convention. Another thing I should mention is these raw passes will only work as float files. So as we're using 32-bit EXRs, this is not a problem. But if there comes a time when you're outputting to something else, you have to make sure that your frame buffer is set to 16 or 32-bit. 8-bit will not do it in this case. Okay, just mention that. So let's create the other one, custom color. There we go. And we'll call this one env indirect. Raw. Okay, now we just need to associate these. So let's pop them in there. MAO raw. Let's rename this one. I don't want that long file name. Okay. Grab both of those, go down to our contribution map and throw them in there. So what we've done here is the same as we did before, but this time instead of writing out diffuse level and diffuse raw, we're writing out the ambient occlusion raw and the indirect raw. Now the Maya Material X has built-in ambient occlusion, so this should give us some sort of ambient occlusion render that's built into the material. In a minute I'll show you how to include a different ambient occlusion map, but for right now we need to just make sure we've got everything. Okay, and we need to do another quick render, so I will see you after that has finished, and we'll be back into Nuke to take a look at how to hook up this indirect raw and our ambient occlusion raw along with our diffuse level and diffuse raw. Okay, back in a sec. Okay, welcome back. Our render is finished and we now have those two other passes, so let's open up Nuke here, and I'm just going to move these out the way. Okay, I'm going to get rid of this grade node because we don't actually need it. And what we need to do now is obviously first things first, let's take a quick look at what our passes look like. So if we pop this open, we should now see we have that end level, which is the diffuse level and the diffuse raw. We should also have, after I've reloaded this file, we should now also have an indirect raw, okay, and we should have an AO raw. But we appear to have none of those things. Okay, let me just check in Maya and see what could have possibly have gone wrong. So there are our passes. Oh, you know what? What we didn't do, which is a simple mistake to make, but I apologize, shouldn't have made it, is we forgot to add these to their own custom color pass. So these first ones, I believe, are all the indirect raws, yes. because obviously what had happened is we were writing the data to the color buffer node, but we weren't actually writing it out to a pass. Silly mistake to make. So let's just check these. Indirect raw, indirect raw, indirect raw. Okay. And obviously you want these ones written out to AO raw. And I would normally take the time to name these. Okay, that's all of our passes now hooked up to these two render passes. That's all of our color buffers written out to these two render passes. So I will now just make sure they're associated. Yes, they are. Okay, I'll render again and see you in a sec. Sorry about that. Okay, our render is finished, so let's now try this once again. Pop into Nuke, reload our image, connect it up to the viewer, and here you can see we do indeed have our indirect raw and our AO raw. And you can see that the AO from these materials hasn't really done a lot for us, and I didn't think it would. The built-in architectural material ambient occlusion has always been a little hit or miss for me, so I like to do a separate AO pass, but we need to know the correct way to composite that together, because as I say, the standard way for most people is just to put it at the end of the chain and multiply it over everything. And this is, well, it does work, and as I say, I have done this myself, and it is a quick and easy way to do it. The problem is it doesn't give the best result. To get the best result, you need to apply the occlusion only over the ambient lighting, or in our case the indirect lighting, hence the name ambient occlusion. It's not supposed to occlude everything, just the ambient light sources. So let's get on with this. So we're going to unhook this now. So we've got this diffuse level, diffuse raw. We need to shuffle in our new passes, so our AO raw and our indirect raw. Let's pull these out here. Okay, and just going to give myself some room to work with here. Connect these up to your input again, which of course is connected to your image, and let's shuffle out the indirect raw. And the AO raw. Okay, now we need to composite all of this lot together. So first things first, we need to multiply these two together. Now if we look at this, you'll see what that's done for us. There we go. Now compositing this is not quite as simple a matter as it might seem. In fact, if you take a look at the mental ray documentation, and you can find this under the mental ray docs, it's the correct way to composite the Maya material. What we're trying to do is indirect raw times ambient occlusion plus the diffuse raw. So let's grab another merge node here. Okay, and we'll hook these up like so. Let's have a look at that. So that's what that's done for us, and this should be plus. Okay, so that's the first part of this, indirect raw times ambient occlusion raw plus diffuse raw. Now we need to times the whole lot by the diffuse level. So once again we need another merge node, and as I said, this is not the simplest thing to do. There we go, and let's connect this back out to our output. And what you should see, if we put this back on RGBA, is that we are having a problem here. We have got a mistake. Let me just check it. Aha, this is on over. It should be on multiply. Okay. Plus, 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 multiply, plus. Let's just take a look at the output from this. Okay, well that does appear to be correct. Okay. So let's go back to our node graph and have a look. And we are far too light. So let's just check we do not have anything like a color correct on here. Okay. Okay, this is actually looking correct to me. So is this. Let's check there's nothing hinky going on in our other groups. Okay. As I say, this can become, see, with all these nodes in now, it can actually become, there we go. Alright, it appeared that I just had a node hooked up wrong here. Now, if you look at this, this looks pretty much identical to what we had before, the beauty pass, and that's good. That's what we're always trying to get back to, the beauty pass. We're just trying to get more control. So now we'll be able to individually color correct. Let's just name these. Indirect, raw, and raw. Okay, now we'll be able to individually color correct these and tweak each one of them. So although this is a little more complicated, it does give a great benefit at the end of the day. That benefit obviously being control. Now, one of the nice facts is now we have this ambient occlusion raw here, we can replace it with another ambient occlusion pass, which will be over our indirect lighting or our occluded lighting. So this is actually how you would do ambient occlusion if you were going to do it right. This is why a lot of people just multiply it over the final image, because as you can see, this is not the simplest thing to set up. It requires some custom color passes and whatnot. So let's dive into Maya and just create ourselves a quick ambient occlusion layer. Now, I showed you this before, but we'll just run through it again. It's a very simple thing to set up, and we'll call this AO. There we go. Now let's put in a material override, which would be, hang on a minute, let's have a look. Overrides, there it is. And we're just going to use a surface shader again. And to this surface shader, we will hook up a mental ray ambient occlusion node. Okay, and I'm just going to give this 64 samples and the distance of, say, 40. This, as we discussed before, this will depend on your scene and the result you're looking for, but I think this will give me quite a nice result. Now I'm going to make sure the master layer is not going to be rendered, and I'm just going to render out this ambient occlusion quickly. So that will take probably about 30 seconds. It should be quite quick. It's a fairly low sample level, so I'll be back in about a minute. Okay, our ambient occlusion pass finished, so let's jump back into Nuke, and all I'm going to do is read it in. Here it is, and if I connect that to a viewer, you can see that we've actually rendered out the ambient occlusion for everything, but when we apply it, it's only going to apply to this one contribution map here. You can then go and apply it to the second one, the third one, the fourth one, but just be aware that this will only be occluding the areas of our contribution map environment, so it will go around these windows, door frame and whatnot. So now we have this AO raw, which we got out of the Maya Material X, which I wasn't happy with, so we're going to unhook it, and we'll just hook this back up to the main viewer. Okay, and instead of using this, which we got out of our Maya Material X, I'm going to use one I made earlier. So let's take this A and throw it up here. Okay, and as you can see, I now have, if I grade this, and let's increase the black point of it. Okay. Why are we not working here? Okay, welcome back. Our ambient occlusion render is finished, so let's just swamp back into Nuke, and you can see here we have this AO raw, which was the ambient occlusion we got from the Maya Material X that I wasn't very happy with. So I'm going to read in our new ambient occlusion, and as I say, this is the correct place to apply this. So what we need to do is put this one in here instead of the AO raw. So unhook this, and we want to hook this up to here, and then we just want to shuffle out the RGB to the RGB, and you can see it looks pretty much the same as what we had before, but if we put a grade node in, I'll show you now we can, and if we look at these windows here, get a better view. Okay, if I increase the black point of this grade node, you can see now that I have control over this occlusion. Okay, and this is the correct, this is the correct workflow for it if you want to do it properly. So there we go. So that is some extra control over the diffuse and diffuse raw, giving you some extra control over your shadows, some extra control over the correct way to do ambient occlusion. And if we should unhook this as well, by the way, this is something I forgot to mention, but the problem we have with this is that we already have an indirect raw up here. Okay, so we do not need this one over here. So that's why our scene was looking a bit bright. So what we can do is we actually can get rid of this merge node now, because we do not need it. So, and put the B up to here. There we go. Perfect. My apologies for that. What I'd done is I'd put the indirect lighting up here and forgot to take it up here, so we had it done twice. But this is actually the correct way. Obviously you don't want two sets of indirect illumination. Okay, so that's all looking good, and as we can see, we got control of this occlusion now on the environment, and all we'd really done with that small error is just have two sets of this indirect lighting. Okay, if we look at the mental ray manual, it now says that what we've done is this, basically, and that should be plus spec, which we are, plus refraction, reflection, translucence and incandescence, or in this case add result, which is incandescence in the Maya render pass. Now I'm not going to bother to do this, the spec level and the spec raw, the reflect level, the reflect raw. I rarely use it, but if you do want to use it, you can obviously just unhook this spec, go back to Maya, pop open your hypershade, put another right color buffer in, and output a spec raw and a spec level, and that's how you would split these up like we've split this up. Okay, I think I'm going to leave this lesson here, and I'll come back in the next one and show you how to do a simple material ID pass for masking if you want to use something like Photoshop or even Nuke, if you don't want to go to all the trouble of creating a whole contribution map. I was going to do that in this part, but I think we've covered enough for one part, so I hope you found this interesting, and I'll see you again in a moment. Thanks for watching. Hi, welcome back. In the last part we left off in Nuke. here with this diffuse level, raw, indirect and AO all split up into separated levels and raws. I did mention that I was going to show you how to do a material ID pass or simple masks as opposed to the complicated contribution maps we've been doing here, and you'll be happy to know that it is substantially simpler than doing all this lot. Okay, so pop open Maya again, and I'm not going to do a ID pass for every single material. I'll just show you one, otherwise we'd be here all day. And let's say I'm going to bring this final result into Photoshop or Nuke or whatnot, and I want a mask for this gloss paintwork, but I don't want to make it its own contribution map. I don't want to go that far. I don't want to go to the time and trouble. I just need a quick mask in case I wanted to, say, increase the contrast on it, or whatever you might use your masks for. So in order to do this, we need to grab this material, and this is door gloss passes. So let's nip open the hypershade. Okay, and find door gloss passes. We'll graph this material, and what we want out of this is a mask. And if you did this is often called a material ID pass. It's done for every material, and they're all split into different colors. But like I said, I'm going to keep this nice and short now. So once again, miscellaneous, right to color buffer, and we need to drop this on here. Other, and what we're looking for is result for the Maya material X. Now if you're using a different material, let's just pull one up. I know I have concentrated rather heavily on the Maya material X during this tutorial, but say you're using a blin and you dropped it on here, what you can do is just use the where has it gone, out color node on the blin. But if we try this with a Maya material X, you'll see that there is no out color. Now we could scroll down each one of these individually, but you can take my word for it, there is no out color. What you need is the result. So you're going to need to show hidden, or you will not be able to see it. And it is here somewhere. Result, there we go. Big material this, and what you want to do, instead of plugging it into the color this time, you want to just plug it into the evaluation pass-through. And do remember, you need to show hidden, or you will not be able to find that. I mention it twice because I've often forgotten myself and spent a very frustrating 5 minutes scrolling up and down this huge material. So now we have the color of this to the evaluation pass-through. So if we take a look at this node, we'll give it a, say, a nice mask color, a bright green, and we need a custom color pass for it. So once again, we'll just pop open our view here. We will add here a custom color, and I'll just call this matte ID pass. So there it is, and I'll rename it. Okay, so we need to associate that, of course, and because I'm using contribution maps, I'll associate it with a particular contribution map, which in this case would be gloss paint. So I'm going to go and now just create a new custom color pass. Custom color, there we go. And I'm going to call it, let's see, okay, so now we've put this in the associated passes. Obviously we need to put it into our gloss contribution mat here, and if we do a render now, what we'll get is a perfect mask for all of the materials that have this door gloss on them. So I will do that, a quick render. In fact, what I'll do is just bring it up in the render view and do one here, because I'm not going to bother loading this into Nuke. I think we all know what a simple mask looks like. And that pretty much brings us to the conclusion of this tutorial. So we've covered quite a lot of ground. If you have any questions, I'm available on the forum. My name is David, and I'll show you this mask, and we'll make sure it works right, and we'll see if we finished or not. Okay, welcome back. I did the first render and I'd forgotten once again to connect this right to color buffer up out to our matte ID pass, custom color pass. So I had to do this twice. Hopefully I've made the mistake now so you won't have to. But remember, you need an input into one of these things and then you need to input out of one of these things. So there we go. If I load in our matte ID pass now, you should see, hopefully, that we've masked out all the areas of this gloss paint. And there you go, perfect material mask. If you were to take this into Photoshop now and put it in a masking channel and whatnot, you can then use this just as a simple mask. Now, if you wanted to mask out other areas, let's say I wanted to mask out our floor, it is quite a simple matter, once again, of just grabbing one of these miscellaneous right to color buffers, throwing the result from the mental ray material. This would be the out color on pretty much every other material, big material that it is, the result to evaluation pass through. Now I'm going to put that on the same matte ID pass layer. There is no point to create a new layer for every one of these, and then I'll make this say red, and when I re-render I'll have this mask that would be red for the floor, or any material that has this, any part of the render that has this material would be bright red, and the gloss paint would be green. So there we have it. That's how you do a material ID pass. You just do this for once for each material you want to mask for, make them bright primary colors so they're easy to select, and that's material ID, or what they call a material ID pass. You don't have to do every material. You can just use it as a simple mask for something like your doorway, or maybe these light bulbs over here that you'd like to add some glow to in post or whatnot. So I thank you for watching this tutorial. I know it hasn't been the sexiest subject you've ever seen, but hopefully it will give you a new level of control over your rendering process. Thanks for watching, and as I said before, you can find me in the forum. My name's Dave if you need to ask me any questions. Cheers.